The process of reasoning is a fundamental aspect of human thought, and it can be approached in two distinct ways: inductive and deductive reasoning. While both methods aim to arrive at a conclusion, they differ significantly in their approach, logic, and scope. Inductive reasoning is a process of making an educated guess or inference based on specific observations or data. It involves recognizing patterns, trends, or relationships within a limited scope and extrapolating them to a broader context. For example, if we observe that it rains every day during the first week of July in Kumasi this year, we might conclude that it rains every first week of July in Kumasi. This conclusion is inductive because it is based on a single observation and implies that the pattern will continue to hold true in the future. However, this conclusion is not absolute, as there may be exceptions or alternative explanations for the rainfall. Let's look at another example: many men are mortal. Many more men are mortal. Conclusion: therefore, it is likely that all men are mortal. In this example, we start with specific observations of many individual men being mortal and infer that it is likely that all men are mortal. While this conclusion is plausible, it's not certain, as we can't be absolutely sure that there isn't an exception, e.g. a non-mortal man who exists. Hence it is inductive. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. In this example, we start with the general rule that all men are mortal and apply it to a specific individual, Socrates. The conclusion is certain because it follows logically from the premises, hence it is deductive. One key difference between inductive and deductive reasoning is the level of certainty attached to the conclusion. Inductive reasoning provides a degree of probability or likelihood, whereas deductive reasoning yields a categorical and absolute conclusion. In our example, the inductive conclusion "it is likely to rain every first week of July in Kumasi" carries a degree of uncertainty due to the limited scope of observation. In contrast, the deductive conclusion "it rains during the first week of July in Kumasi" is more certain because it is based on prior knowledge and general principles. Another significant difference lies in the scope of application. Inductive reasoning typically deals with specific instances or phenomena, whereas deductive reasoning can be applied to broader domains or universal truths. In our example, the inductive conclusion only applies to Kumasi during the first week of July, whereas the deductive conclusion can be extended to other areas and times within the rainy season. Furthermore, inductive reasoning relies heavily on data and observation, whereas deductive reasoning relies on established principles and rules. Inductive reasoning may require additional data points or further observations to refine or disprove its conclusions, whereas deductive reasoning relies on established knowledge that can be applied universally. In conclusion, while both inductive and deductive reasoning are essential tools for making sense of the world around us, they differ significantly in their approach, logic, and scope. Inductive reasoning involves making educated guesses based on specific observations and carries a degree of uncertainty, whereas deductive reasoning involves deriving conclusions from established principles and yields categorical certainty. Our example highlights the importance of understanding these differences to effectively navigate complex issues and make informed decisions. By recognizing when we are engaging in inductive versus deductive reasoning, we can develop more nuanced and accurate conclusions that reflect our understanding of the world.